In this lesson, we will use the factor theorem to write linear factors of a polynomial. Recall with the factor theorem that if a polynomial x minus k, which is the divisor of a polynomial function, if f of k equals 0, then k is a 0 of that polynomial. So here we're asked to determine whether x minus 1 is a factor of the given polynomial. So we can use the factor theorem, or recall you can also just simply evaluate it for that number, plug it in and see what your output would be. Either method would work fine. Now if we're going to use the synthetic division method, remember you can't use the synthetic process with x minus 1. You're going to have to solve for x of that number. Just get a number. So x minus 1 equals 0. If we were to solve for x, you would have to add 1 to each side, and x would equal 1. So 1 is going to be your divisor. That's going to be on the outside of the synthetic division process. And then again, recall you're going to take your coefficients and they're going to go underneath the symbol. So as I said before, you could also evaluate it for that function, plug in f of 1, and if when you do that, if you get a 0 out, then yes, that means that f of 1 is a 0 of the given polynomial. But let's go ahead and do the synthetic division. So recall we have the 1 on the outside and the coefficients under, so let's go ahead and begin the process. I'm going to bring down a 2, multiply that with 1 to get 2. Bring down a 2, multiply that with 1 to get 2. Bring down 5, multiply that with 1 to get 5. Bring down 0, multiply that with 1 to get 0. Bring down a 7. We do not have a 0 at the end for our remainder. We have a 7. So therefore, there is our proof using the remainder theorem that 1 is not a factor of the polynomial given. Okay, so it's just a matter of the same thing you've been doing, using the synthetic division and the divisor to determine whether that number of 1, in this case, whether it is or is not a factor of that polynomial. And it's only a factor is if your result of dividing the polynomials that you wind up with a remainder of 0. So there you have it, the factor theorem. Let's do another one. We want to determine whether x minus 1 is a factor of this given polynomial. And yes, that is a long polynomial. So let's go through there and identify the coefficients. So our first coefficient is a 3. Next, we have a negative 2. Next, we have a 1. Next, we have a negative 8. Next, we have a 5. And lastly, we have a 1. So when we solve for x, for our variable here of x, x will equal 1. So 1 is going to be on the outside of our synthetic division process. Let's go ahead and begin the process. I'm going to bring down a 3, multiply that with 1 to get 3. Bring down a 1, multiply that with 1 to get 1. Bring down a 2, multiply that with 1 to get 2. Bring down a negative 6, multiply that with 1 to get negative 6. Bring down a negative 1, multiply that with 1 to get negative 1. bring down a 0, and yes, this one we do have a remainder of 0. So therefore, we can conclude that 1 is a factor of this given polynomial. And there you have it, the factor theorem. Linear factorization theorem. An nth degree polynomial has n number of zeros or roots. An nth number of polynomial has n number of linear factors. So what does that mean? So whatever is the highest degree of a polynomial, that will tell you how many zeros or how many roots there are. It will also tell you how many linear factors you will have of that polynomial. So here's what we mean. In this example here of the given polynomial, out of all the terms, the highest degree is the degree of 3. So that means this polynomial will have 3 zeros and 3 linear factors. Here's an example of what that polynomial factors into, and they have 3 linear factors here. So you can identify the number of zeros or linear factors simply by determining the highest degree of all the terms of the polynomial. So it says factor this given polynomial into factors if -3 is a 0 of this function. So they're already telling us that -3 is a 0 of this polynomial function. So if we were to plug that into the synthetic division, we're going to have a remainder of 0, because recall, if a number is a factor of a polynomial, it will have a remainder of 0. So let's go ahead and use synthetic division so that we can find out what are the linear factors of this. In other words, we want to do just what you see in the above example, where you're given a polynomial function and then you rewrite it as a linear factorization. And so that's what we want to do for this given polynomial. And to do that, you're going to have to use the synthetic division. So let's go ahead and we're going to put our -3 on the outside as our divisor, and we're going to use the given coefficients to write under the symbol so that we can begin our synthetic division process. So let's begin. I'm going to bring down a 6, multiply that with -3 to get -18. Bring down a 1, multiply that with -3 to get -3. Bring down a -1, multiply that with -3 to get +3. Bring down a 0, and again, we already knew that we were going to have a 0 because we were told that -3 was a 0. Our quotient, remember when you write it, you have to fill in your x's because the synthetic division only gives you the coefficients. And you remember, you're going to always write it as 1 degree lower, so our highest degree was 3. So 1 degree lower means it will start at 2, so 6x squared plus x minus 1. That is your answer or your quotient. Your divisor is -3. And recall, if we put that back in the form of x minus k, it would be x plus 3, the very opposite. So then writing everything as linear factors, we have one more step, which by the way, here we have the divisor times the quotient, which equals the polynomial. But we need to factor this trinomial into two binomials. So using factoring trinomials, the knowledge from previous course, you learned how to factor trinomials. That's going to give us a final answer of x plus 3 times 2x plus 1 times 3x minus 1. So we just factored the trinomial there. It factored into 2x plus 1 times 3x minus 1. And we already had our divisor, which was x plus 3. And so there you have it, linear factorization of the polynomial. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.